Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future today. Imagine this scene, it's 2 a.m. A developer stares at a failing test. The code looks correct, but the system still breaks. Now, here's the question: what if the AI helping you debug only understands frozen snapshots of code and not how that code evolved? That's the story behind a research paper called IQuest-Coder-V1 Technical Report by Jian and Zhang. And today, I want to tell you that story. Let's start with the problem. Most code language models learn code like a photograph: one file, one moment, one answer. But real software doesn't work that way. Real code lives in motion. Commits break things, patches fix them, tests fail, then pass, then fail again. And that's where traditional models struggle. They generate code well, but fall apart on long tasks, multi-file changes, agent workflows, real debugging. So the IQuest-Coder team asked a different question: what if we trained models? The same way software actually grows, not just what the code is, but how it changes over time. That idea became something called code flow training. Think of it like this: instead of showing the model a finished movie frame, you show it the entire timeline from first draft to final release. Here's how the journey works. First comes pre training. The model learns general language and huge amounts of code. Then it's annealed on carefully curated, high quality repositories. This step is about foundations, syntax, structure, style. Nothing fancy yet, but absolutely critical. Then comes the turning point: mid training. This is where things get interesting. The model is exposed to reasoning traces, agent trajectories, and long context code dot first at 32K tokens, then all the way to 128K. It doesn't just answer questions anymore, it plans, it executes, it sees logs, errors, test outputs, and learns how actions lead to consequences. This stage teaches the model how to think through code, not just complete it. Now comes a clever fork in the road. Post training splits into two paths: the instruct path optimizes for being a great assistant, clear answers, helpful code, strong defaults. The thinking path goes deeper. Here, reinforcement learning is used to reward long horizon reasoning, self correction, error recovery. This is the version that can fail, pause, rethink, and try again. That's rare and powerful. But there's one more twist: deployment. Big models are expensive, memory is tight, latency matters. So the team introduced loop coder. Instead of stacking more layers, the model reuses them, looping through the same transformer blocks multiple times, like rereading a paragraph. Instead of buying a bigger book, same parameters, more depth of thought. It's an elegant trade off between intelligence and efficiency, and the results across benchmarks like SWE-bench, Live Code Bench, Terminal Bench, and Full Stack Bench. IQuest-Coder V1 doesn't just compete, it leads among open models, especially on agentic tasks, the kind where code has to act, not just exist. But here's the real takeaway: this paper isn't just about stronger model, it's about a shift in mindset from static code to living systems, from single answers to evolving reasoning. And by releasing the entire training chain, from pre-training to final models, the authors invite the community to study how intelligence is forged step by step. So the next time your AI debugger actually fixes the bug, understands the repo, and recovers from failure, remember this idea: code doesn't stand still, and now neither do the models that write it. If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.